This work presents the Collision Affording Point Tree, or CAPT, a data structure which accelerates collision checking against point clouds for robot motion planning. In this demonstration, we show a UR5 manipulator planning between 3 preset waypoints in an unmodeled tabletop environment. We construct CAPTs from live sensor data streamed in from a camera on the ceiling. 60 times per second, we receive a new point cloud, construct a new CAPT, and generate a new motion plan. All video in this demonstration is played back at 1x speed, and the online planning system is running in real time. Let's see what happens when we introduce a new obstacle to the scene. The robot immediately replans to reactively dodge the obstacle, which, again, is not modeled and is only provided as a raw point cloud. Since we are generating a full motion plan at each frame, the robot can maneuver around any obstacle as long as a sampling-based planner can solve the problem. Planning using the CAPT is fast enough that the robot can also dodge dynamic, unmodeled obstacles. The CAPT can even represent cluttered environments without performance degradation. When an obstacle is removed, the robot can immediately take advantage of the newly freed space to move in a more efficient path.